As our programs become more and more complex, and as we begin to run into situations where we have repetitive tasks or we have lists of data, we run into situations where we have to process those items. So we have to do repetitive things to accomplish those repetitive tasks, or we have to iterate over each of those items in a list in order to do something with them, whether that be process them, do some kind of calculation with them, some kind of algorithm operates against them, whether we push them into a database or we're sending them across an API. We deal with lists of data all the time in our programs, as well as repetitive tasks. And for that, we need to understand how we do loops, or how we iterate over those items as we run into them in our programs. So let's go ahead and let's get up in our list those items that we're going to be running into, and figure out how we're going to deal with each of them. So here we're going to have repetitive tasks. That's a big category of stuff that we run into as we are building software. And then we also have lists of data. That's another big one that we run into. So when we run into those types of issues in our software development, we need to be able to iterate. And iteration is just a fancy word for saying looping, and looping is just a really fancy way of saying going over and over and over and over, doing the same thing. Now, if you think about it, with the way I just said it, repeating something over and over and over again is definitely a useful ability. But what happens if we never stop repeating that code over and over again? And that is where we run into what is called an infinite loop. Now, we've all experienced infinite loops in programs that we've used where our program seems to have become unresponsive. In other words, we're sitting there using it, and then the user interface just freezes up. We can't move the app, we can't click on a button, we can't do anything. The program is just frozen. A lot of times in the back end where the code has been running, some condition has happened where a loop, where the programmers have set up some kind of repetitive task or they are looping through data, they have that going on and they have not created a condition, or the condition never changes, that allows that looping to end or for us to break out of that loop. And when that happens, the application freezes. And usually the operating system will then shut that application down, or you have to go do a force quit on it. And then you have to restart the application and pick up from where you left off if you haven't lost too much data or what you've been doing. So let's talk about how we do this and how we make sure that we don't ever have infinite loops running in our applications, and how we handle these repetitive tasks and lists of data effectively through the use of loops. Once we understand the basics of loops, then we'll move on to the different structures that are provided by JavaScript in accomplishing different types of looping. And we'll run into those, and we'll do a video for each of them after we complete the understanding of basic loops. So let's start. We've got our repetitive tasks, and we've got ourselves a list of data. And as we just spoke about, to avoid infinite loops, we have to have a pretty strong condition. And let's go ahead and add that right here, a condition that we check every time we begin to loop over one of these two things again. So this condition is extremely important. This condition determines whether or not we continue to loop, or whether or not we stop and then continue on with the rest of our program. So if condition is true, let's go ahead and add that in there. If this condition is true, we want to go ahead and move on with the rest of our application. So let's say continue rest of program. All right. So that's our condition right there, is that if the condition is true, we want to go ahead and move on with the rest of our program. And then if the condition is not true, so if we end up with false, so let's go ahead and say false right here. The condition is not true, meaning that we probably still need to complete something else in the task, or we have more data in our list. Then we want to go ahead and, if false, we want to go ahead and process the code. So we've got some code down here, and let's just say code I want my right color. Let's go ahead and get the right color in there. We want to do the code. Let's select my proper color. We're going to do the code in loop. So this is the code that is going to be processed. Now this code, just so we can be explicit here, is either the repetitive task code, or it is going to be code that handles data in list. All right, and that's what that code does, and it's inside this loop. So let's make sure we get our arrows in there so we know how things are flowing. So if the condition is false, we're going to go ahead and execute the code in the loop again. Now, right here, if I went directly back to just the condition, what's going to happen here is that if the condition was true to start off with, we never would have looped over the code, and we would have just gone right on with the rest of our program. If the condition was false, we would have executed the code in the loop, gone back to the condition, it would have remained false because nothing has changed the condition, and we would get ourselves an infinite loop. And of course, we're trying to avoid infinite loops. So what we need over here is we need to change the condition. So change condition. And this is a question. And the question is, should we change the condition? So should we change the condition is really the question. And what we're really asking here is, are we done doing what we need to do? So that would be, is the repetitive task complete? And if yes, then we change the condition. Or are we through the list of data? So is the data in list fully processed? So those are the kinds of questions we would be asking ourselves as to whether or not we should be changing the condition that we are operating everything off of. In other words, whether or not we continue to loop. And this right here, let's make sure this is super explicit. This is a check on the condition. So we're checking the condition to see if it's true or false. And if it's true, we're going to continue with the rest of our program. If it's false, we're going to do the code in the loop again, and we're going to process that task again, or else we're going to process another item in the list of data. And then we're going to go ahead and ask ourselves the question again. Should we change the condition? Is the repetitive task complete? Is the data in the list fully processed? If those come back to true, the condition changes to true, and then we move on with the rest of our program. So this is the basics of looping. So now we ask ourselves, what is the condition? Like, how do we know what the condition is? Usually a condition in a loop, we are going to be checking something from our application. So maybe in a repetitive task, maybe this repetitive task requires that we do something a certain number of times. So we may have a counter that we're going to be using for counting how many times we have done the repetitive task. So we might have a counter. We also might have a counter if we have a list of data and we know how many pieces of data we have in the list. So we would know the length of that list of data. And we might have a counter. So the counter might have to do with, are we checking to see if this counter has executed the number of times required for this repetitive task. So let's add something like that. Number of times task needs to run. So that's going to be a potential right there. And then we already said that perhaps this list, we know the length of the list. So we know how many items are in the list. So the condition right here is going to be something like this. Let's add something right here. So we might have, so the number of times task, so we'll say that refers to that other one, is that equal, and let's use the proper equal, to the counter. If it's equal, then we probably need to move on with our program, right? Because we've hit the number of times that the task needs to be run. So if the number of times the task needs to run, if this counter is equal, because we're incrementing it right here, then the condition would change to true, and we would move on with our program. If the number of times the task has executed is less than the counter, it's going to be false. So we're going to continue on with doing this. And so in our example right here, when we change the condition, like is the rep task complete, the repetitive task complete? Well, in our example right here, we have a counter, and so we're actually incrementing the number of times the task has been complete. So let's say number times task, and then we'll just do a plus plus, meaning that we're adding 1 to it. So this is where we're changing the condition, and we're going to see that change up here. We're going to check. So the first time we go through this loop, times of task might be 4 because we need to run it 4 times. And each time we loop through this, it may start at 0 the first time. And so 0, is it equal to, well, let's see, times task equals 4. Is it equal to 0? No. So we continue our loop, we increase it by 1, and now the counter is at 1, and times task is still at 4 because that's how many times it needs to run. Is that equal? No. So it goes to false. So we run our code again. We increment our counter again as this condition change. Now we're at 2 times in the counter, and 4 times is how many times we need to run the task. So are they equal? No. We go through again. We increment. Now we're at 3. Is 3 equal to 4? No. So we do the loop again. We increment our counter. Is 4 equal to 4? Yes. So we break out of our loop, and now we continue with the rest of our program. So this provides us a basic understanding of how looping works inside of pretty much every programming language out there. And here we're talking specifically about JavaScript. And we used a counter example. In our list, instead of using the number of times a task needs to execute, we may use something like the length of the list equals the counter. So these are just examples, right? So here, first time we go through, counter is 0 because it's the first time we're going in. We execute some code on the list, we pull some data out, we do something with it, we push it into a database, whatever it is that we're doing. We increment our condition by 1, and then we do the check again. Is the length of the list, which maybe we've got 5 in here, is it equal to 1? No. So we continue on until we have a counter and we have counted that we have gone through the length of the list, exactly the length of the list, and then we break out of that loop. So this is basic looping in programming. This applies to pretty much any programming language you're going to learn. So make sure you understand this. Make sure you go through this video a couple of times. If you have any questions, make sure you talk to the instructor or to the tutors. And make sure you understand the basics of how looping works, what a condition is, how we can come up with conditions based on what we're doing, repetitive tasks, or where you're working with lists of data, how we may ask ourselves questions about whether the condition should change, and how we might change that condition, in this example using a counter, and then figuring out how we come up with a check that would tell us when to break out of the looping. And the check has to be rock solid so that we don't end up with an infinite loop.